On the left, we have our wallet side, and on the right, we have our blockchain side. Let's go to our projects. We see we have two folders, block and wallet. We're going to send this through our network shortly, but right now, we don't have our network, so we'll pass this information using our code. We want to use the struct for signature here in our blockchain side as well, so we'll create a new directory here. We'll select Go Blockchain, New, then Directory, and name this as Utils. We have our Utils folder, and with this, we want to click on New Go file. We'll name this ECDSA, and from now, we want to move our shared code for our signature. And let's click on OK. In one of our previous lectures, we wrote the signature section within our wallet. Let's go to our wallet folder, and this is the code we wrote for signature. We want to copy and move it. Here, I deleted this, and inside our ECDSA package, we'll copy this. There's times where the package is automatically imported, but that's not all the time. So I'm going to write FMT here. And with this, what we've done here is we moved our signature inside utils. Now let's go back to our wallet.go. We see an error for our signature. What we'll do is go up to the top, and we moved this section already, so let's delete it. We moved it to this Go Blockchain utils. Inside our utils is where our signature is located, and the red text is where our error is occurring, so let's include utils in front of signature. Now we've rewritten this to say that we're going to be using signature that's located inside our utils package. Now let's go back to blockchain.go. Here too, we'll include import Go Blockchain utils. And we'll be using signature here as well. And now here we have add transaction. Below our add transaction method, we'll write our code. We want to write some codes to verify, so we're going to say BC blockchain, and our method name will be verify transaction signature. For this, we need 3 pieces of information. First is sender public key, followed by ECDSA public key. Then we have util signature. And our third piece is transaction. This is for verification purpose to see whether this is possible or not, so we'll return a bool. This is our method. Now, how will we verify? First, we'll write JSON marshal, then transaction. We'll marshal JSON from transaction. We'll make this into a hash. Then SHA-256 sum256 byte m to take out the hash, which is then followed by return ECDSA verify. If you recall, we did this when we went over the Go document. We'll store sender public key, then pass in hash, signature R, and signature S. And this is how we can verify. Let's look at our visual to the right, and the right side, we have public key, signature, and our transaction. These are used to verify. This is the method we just created. Now, using verify transaction signature, we want to verify and see if we can add transaction to this blockchain node. When we call on add transaction, if we can verify, then we want to add transaction. If we can't verify, then we don't want to add it. With that being said, we'll focus on rewriting our add transaction method from now. Right now, we have our sender, recipient, and our value, but let's add on to this. What we're going to add is sender public key, followed by ECDSA public key, then SUtils signature. We've added on our argument, and we already recreated a line for a new transaction. After this, we're going to add if BC verify transaction signature. We'll call on this and pass in sender public key S and T. We can verify this, then we want to add it to the transaction pool. I just moved the line that was located down below, If this returns as true, then this meets the condition. Later on, we want to see if this returns as true or not, so we'll add bool. For the times we aren't able to verify, let's include a log here. Log println followed by error verify transaction. This is a log for error, followed by return false. Now let's look to the right. For example, if person A wants to send to person B, we want the blockchain to verify. I have another visual that I want to bring up here. Let's say this person is a miner and provides this blockchain node and will receive a reward when mining. In this scenario, the sender is this blockchain node side. For times like these, verification signature isn't necessary. In this case, we want to return true. So we'll say if sender is the mining sender, and we previously wrote the blockchain. So if the sender is the miner, this is simply a reward that's being sent. So in this case, we'll use append and simply put in the reward into our BC transaction pool. We'll simply return true. This add transaction, this was included in our mining. So let's go to our mining method. In our mining method, we see that this is showing up as an error. This is when we're going to be rewarding, so we don't need a public key or a signature. And that's why we'll enter nil and nil here. We'll return to add transaction now, and this latter part with our public key and signature. We don't need this when giving out the reward in our blockchain node. All we need to do is append and return true. Now that we've gotten this far, let's go back to main.go. We have the lines for print, but we don't need this right now, so let's delete. This section for wallet, we'll enter wallet M, meaning the miner's wallet. Let's copy this line and paste 2 times. This will be person A's wallet, and this will be person B's wallet. And for this transaction, we'll rewrite this to A, and same here. This will be wallet A, and same for the third one. It will be wallet A, and then for the blockchain address, it will be wallet B. This is our transaction, and let's say that this is our wallet side. Next, we'll be creating the blockchain node side. We'll be writing blockchain and blockchain new blockchain. And just now, this automatically updated, but we imported as go blockchain block. We'll be calling the new blockchain and pass in person M's blockchain address. When mining is performed, then this person M can receive the reward. We've created our blockchain node, so we're going to add is added. We're using this to see if the transaction was really added to the blockchain node side. We're going to add a bool, so that's why we have is added. And we're going to write add transaction. To this, we're going to add person A's wallet's blockchain address and person B's wallet's blockchain address. After this is value, we'll pass in wallet A's public key and generate signature. We have 5 pieces of information here. Let's review this by referring back to our visual. I'm going to bring it up to the right. And we have our public key, signature, and sender, receive, value. We have 5 pieces of information here, and we pass in that information. Our blockchain node side will verify the transaction by referring to this is added. Once this has been completed, we'll add fmt println added and is added. Let's run our code with what we have now. And now we see below, added, true. Verification has been completed. Now I want to review add transaction one more time, so let's go into add transaction, where person A sent cryptocurrency to person B. We have this BC transaction signature. Once we're here, then we have person A's public key and the signature used for the transaction and transaction. The 3 pieces of information is used for ECDSA verify method, and that's how true is returned. We'll refer to this and return true. Now let's go back to our main, so we'll click on main.go. We want to do the mining portion, so for this we'll write blockchain mining. And let's see what's inside our blockchain. Next, let's write fmt printf, then person A. and the amount of cryptocurrency held by person A. So for this, we'll say blockchain calculate total amount, followed by person A's blockchain address. Let's copy this line and rewrite this for person B and person M for miner. So this section will be wallet B and also wallet M. Let's run our code with this, and when we do, we see person A made a payment to person B, so -1 value is showing. B gained 1 value, and for mining, the miner did the mining, so value is 1. We can look at what's inside the blockchain. We see the same mining reward information. Now let's go back to our code again. We had our add transaction. Then when we performed mining, we ran the code with this and returned true. That's how we're able to add transaction. And referring to our results, person A's wallet is showing value -1. In the real world, you can't send cryptocurrency if you don't have any to send. So from now, let's add more to our code that will account for the situation. Please go to Add Transaction, and after the transaction has been verified here, let's include an if function. If BC calculate total amount. When the sender wants to send a value that's more than what they currently have, they shouldn't be able to send it. For this, we'll write log print ln error, not enough balance in a wallet, followed by return false. Now that we have this, when we run our code, we see this time person A 0.0, and same for B and M. No transaction has taken place. When we scroll up a little, we see in our log not enough balance in wallet. Because person A didn't have enough to send, person A wasn't able to send any. And that's how this if statement works. Person A will have to perform mining and earn cryptocurrency or send money to someone to receive cryptocurrency if person A wants to get some crypto money in his or her wallet. Now that we've covered this if statement, if we run our code with this during our demo, then we're going to run into a situation where person A won't be able to make any transactions. So for now, let's comment this out. Later on at the end of all of this, we can uncomment this. But for our scenario, let's comment out this calculate total amount. We'll be moving on to our next lecture, but let me explain a little more about this section of our code. This section of the code, the syntax here is not lined up. If you write go fmt-w block blockchain go, you can clean up the lines and make it look more organized. I ran the code and we do see that this section is all lined up. We can do the same for main.go and also utils ECDSA and also wallet.go. Now let's move on to our next lecture.